Hi students, in this lecture I will discuss magnetic quantum number and spin quantum number. In previous lecture I had discussed about concept of quantum numbers, principal quantum number and azimuthal quantum number. Let us start magnetic quantum number. Listen. Magnetic quantum number explained to Zeeman and Stark effect, and in reverse statement to explain Zeeman and Stark effect, Lande introduced concept of magnetic quantum number. Listen, for MCQ, Zeeman and Stark effect explained by magnetic quantum number. If in your mind it is arises what is Zeeman effect and what is Stark effect, I will explain. Again I am repeating, magnetic quantum number explained to Zeeman and Stark effect, and magnetic quantum number introduced by Lande. Lande is name of scientist. Clear? Clear? Now I will discuss Zeeman effect. Zeeman effect means a splitting of a spectral line in magnetic field. I am repeating, a splitting of a spectral lines in magnetic field is known as Zeeman effect. And second is a Stark effect. A splitting of a spectral line in electric field is known as a Stark effect. Clear? A splitting of a spectral line in magnetic field, Zeeman effect. A splitting of a spectral line in electric field, a Stark effect. And it is clear from both statements, electron has both electrical and magnetic behavior, because when electron pass through electric field affected, and when electron pass through magnetic field also affected, and it is clear from this statement, electron has both nature, electrical and magnetic. Clear? Look at both. Topic quantum number. To explain Zeeman and Stark effect, Lande, and it is name of scientist, introduced concept of magnetic quantum number. First term, Zeeman effect, a splitting of a spectral line in magnetic field, Zeeman effect. Second is a Stark effect, a splitting of a spectral line in electric field known as a Stark effect. Next, listen, value of magnetic quantum number always depend upon value of azimuthal quantum. Value of magnetic quantum number always depend upon value of azimuthal quantum number, and value of magnetic quantum number is equal to minus L, and L is azimuthal, through 0 to plus L, but only integer. Magnetic quantum number never in fraction, but negative integer, positive, 0 to minus L, where L is azimuthal, and 0 to plus L, L is azimuthal. Listen, we know that for S-Suborbit, L is equal to 0, for P-Suborbit, L is equal to 1, for D-Suborbit, L is equal to 2, and for F-Suborbit, L is equal to 3. Listen, value of L, one column, value of M, second column, number of value of M, third column. It's number of value of M. Listen, when L is equal to 0 for S, m equal to 0, 2 minus 0, 0, that means 0. And when value of m 0, it is 1 in number, and hence number of value of m is equal to 3. Again, L0, m, 0, 2 minus 0 plus 0, that means 0, and number of value of m is 1. Now, when L is equal to 1 for P-Suborbit, L1, 0, 2 minus L, and L is 1, so 0, 2 minus 1, and again 0, 2 plus 1, so 0 minus 1 plus 1. It may be written as 0 plus 1 minus 1. It's not necessary minus 1, 0 plus 1. It may be plus 1, 0 or minus 1, and hence number of value 1, 2, 3. Number of value of m is equal to 3. When L is equal to 2, value of m 0, 2 minus 2, and all integer between 0 to minus 2. So 0, minus 1, minus 2, and plus 1, plus 2, and it may be written as plus 2, plus 1, 0, minus 1, minus 2, and hence number of value of m is equal to 1, 2, 3, 4, 5. Number of value of m 5. When L is equal to 3, F-Suborbit, and value of m 0 to minus 3, 0 to minus 1, minus 2, minus 3, and again 0 to plus 3, plus 1, plus 2, plus 3. It may be written as plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3, and number of value of m 1, 2, 3, 4, 5, 6, 7, and it is equal to 7. Clear? Always keep in mind value of m 0 to plus minus L. I am repeating, value of m 0 to plus minus L. Next, listen, number of value of m gives number of orientation, and orientation means arrangement. Orientation means direction. Orientation actual meaning is arrangement. Number of value of m gives number of orientation of electronic cloud, and number of orientation gives number of orbitals. I will discuss what is orbitals and how to define orbitals. Listen, first term, number of value of m, number of orientation, number of value, and we know that L0s, m equal to 0, number of value of m, and hence a spherical shape has one orientation. But when L is equal to 1, m equal to minus 1, 0 plus 1, number of value of m 3, and when number of value of m 3, then it has 3 orientation, that means dumbbell has 3 arrangement in a space. Listen, and number of orbitals of electronic cloud is equal to number, listen, number of orientation of electronic cloud is equal to number of orbitals. I am repeating, number of value of m, number of orientation of electronic cloud, and number of orientation gives number of orbitals. And definition of orbital, listen, the 3-dimensional area around the nucleus, the 3-dimensional, always keep in mind, orbitals are 3-dimensional. In previous lecture, when I discussed concept of orbit, listen, orbit is circular. Orbit is circular path, and orbit is 2-dimensional, but orbitals are 3-dimensional. So the 3-dimensional area around the nucleus where probability of finding of electron is maximum, and where probability of finding of electron is maximum called orbitals, and maximum probability means not 100%. Maximum means when 90 to 95%. Maximum probability means 90 to 95. That is, when probability of finding of electron will be 90 to 95% called orbitals. Listen carefully. Number of orientation is equal to number of orbitals. Next, when L is equal to 0, look at both. When L 0, M 0, because M equal to minus L, 0 to plus L, L 0 and hence M 0. But when M 0, number of value of M is 1. A spherical shape has only one orientation and hence S has only one orbital. Listen, it is a spherical shape and only one way to draw a sphere, and hence a sphere has only one orientation. Now, second, when L is equal to 1, L is equal to 1, P. When L is equal to 1, P, M is equal to minus 1, 0, plus 1. Listen, L1, M equal to minus L, 0 to plus L, minus 1, 0, plus 1. Number of value of M is equal to 3. Number of value of M is equal to 3. And hence, dumbbell shape has 3 orientation. Therefore, P has 3 orbitals. Listen, P is suborbit, but it has 3 orientation. One orientation is Px. One is Px. And listen carefully. Px means dumbbell lie on x-axis. Clear? I am repeating. Px means dumbbell lie on x-axis, and when dumbbell lie on x-axis, maximum probability of finding of electron on x-axis, and hence Px is called orbital. Clear? Px is called orbital because dumbbell in x-axis, maximum probability of finding of electron on x-axis, and hence Px orbital. Second is Py. When dumbbell on, second is Py. Second is Py. And Py means when dumbbell lie on y-axis. Dumbbell lie on y-axis called Py. And third is Pz when dumbbell lie on z-axis. I am repeating. P has 3 orientation. Px, dumbbell lie on x-axis. Py, dumbbell lie on y-axis. And Pz, dumbbell lie on z-axis. And Px means when dumbbell lie on x-axis, and it means probability of finding of electron on x-axis will be maximum, and hence Px is called orbital. Py is called orbital because in case of Py, dumbbell lie on y-axis, and when dumbbell lie on y-axis, probability of finding of electron on y-axis maximum. Pz, it is Pz when dumbbell on z-axis, probability of finding of electron on z-axis will be maximum, and called Pz is called orbital. Clear? And hence P-Suborbit has 3 orbitals, Px, Py, Pz. Clear? And each orbital perpendicular with each other. One most important objective, Px, Py, Pz are perpendicular with each other. Clear? Next. When L is equal to 2, L2 for D-Suborbit, M equal to minus 2, minus 1, 0, plus 1, plus 2. Number of value of M, 1, 2, 3, 4, 5. Number of value of M is equal to 5, and hence double dumbbell shape, double dumbbell, D has 5 orientation, hence D has 5 orbitals. Listen, S has 1 orbital, P has 3 orbitals, and D has 5 orbital. Name of first dxy, and dxy means because D has double dumbbell shape, both dumbbell lie between x and y axis. Listen, in 3-dimensional figure, it is very clear when dxy, then both dumbbell lie between x and y axis. Both dumbbell lie between x and y axis. Dyz, both dumbbell, because D means double dumbbell. both dumbbell lie between y and z axis. Dzx, both dumbbell lie between z and x axis. Dx square y square. One dumbbell lie on x axis, other dumbbell lie on y axis. I am repeating. Dx square y square. It's not dx square minus y square. X square y square. One dumbbell lie on x axis, other dumbbell lie on y axis, and other is fifth is dz square. One dumbbell lie on z axis and other dumbbell rotate along z axis. I am repeating. Dz square means one dumbbell lie on z axis and other dumbbell rotate along z axis. There are 5 orbitals. I am repeating. dxy, both dumbbell lie between x and y. dyz, both dumbbell lie between y and z. dzx, both dumbbell lie between z and x. dx square y square, one dumbbell lie on x axis, other dumbbell lie on y axis. dz square, one dumbbell lie on z axis and other dumbbell rotate along z axis. Clear? When L is equal to 3, F, M equal to minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3, and number of value of M is equal to 7, and F has 7 orientation because number of value of M is equal to number of orientation, and hence F has 7 orbitals, fx cube, fy cube, fz cube. Fx y square z square, fy z square x square, fz x square y square, and fxyz. Clear? Now, next. In a diagram, orbital represented by a square. In diagram, orbital represented by a square. Clear? And we know that L equal to 0, S, M equal to 0, S has one orbital, and in diagram represented by one square. When L is equal to 1, look at both. M equal to minus 1, 0, plus 1, there are 3 orbitals. In diagram, 3 orbitals, but all 3 orbitals connected with each other because each have same energy, all have equal energy. Why equal? I will discuss. Listen, 3 orbitals all have equal energy, and equal energy called degenerate orbitals. Listen, one term degenerate orbital. Degenerate means having equal energy. All 3 orbitals having equal energy, and hence all 3 orbitals are in folding term, fold. 1, 2, 3, minus 1, 0, plus 1. It may be written as plus 1, 0, minus 1, but all 3 are in folding term, and because all 3 have equal energy, and equal energy called degenerate. When all 3 orbitals minus 1, 0, plus 1 value of M are correct, but when all 3 orbitals represent separately, then it is wrong. अगर ये आप अलग अलग राइट कर देंगे तो ये क्या होगा? रॉन्ग हो जाएगा. Listen, L is equal to 2, D, M is equal to minus 2, minus 1, 0, plus 1, plus 5. There are 5 orbitals, all 5 orbitals connected with each other in folding term. It may be written as plus 2, plus 1, 0, minus 1, minus 2, all 5 connected with each other. Never write in separate, because in separate means all have different energy. But we know that in absence of electric and magnetic field, energy depend upon N plus L. Why? All 3 have same energy because all 3 orbitals having different value of magnetic. But in absence of electric and magnetic field, energy depend upon only principal and azimuthal, and for all 3 orbital N and L are equal, and hence all have same energy, and same energy orbitals always retain with connected with each other and hence called degenerate orbitals. Similarly, when L is equal to 3, F minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3, 7 orbitals and called sevenfold degeneracy, and it may be written as plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3 and called sevenfold. Listen, S has only one orbital, P has 3 and called threefold degeneracy. D has 5 called fivefold degeneracy. F has 7 called sevenfold degeneracy. Clear? Next. Listen. A spin quantum number. A spin quantum number gives a spin motion of electrons in atomic orbit. Listen. A spin quantum number introduced by two scientists, one is Ahlenbeck and Gauss-Smith. I am repeating, a spin quantum number introduced by Ahlenbeck and Gauss-Smith. And according to Ahlenbeck and Gauss-Smith, the electrons moves its own axis in a spin motion. Electrons move its own axis in atomic orbit. That means electron has a spinning motion, and there are two types of a spin motion, at clockwise, anti-clockwise. Clockwise value normally plus half, anti-clockwise minus half, but it is not fixed. For clockwise maybe minus half, for anti-clockwise maybe plus half, but normally for clockwise plus half, for anti-clockwise minus half. Next, in diagram, orbital represented by a square. In diagram, upward a spin called clockwise, downward called anti-clockwise, and for clockwise normally plus half, for anti-clockwise minus half, but it is not necessary, it is not fixed. For clockwise maybe minus half, for anti-clockwise maybe plus half, but normally for clockwise plus half and for anti-clockwise minus half. Next, a spin quantum number gives a spin angular momentum of electron. Listen, a spin quantum number gives a spin angular momentum, and formula of a spin angular momentum root under mod s into mod s plus 1 into h by 2 pi. For any electron, s is equal to plus minus half, and after taking mode it will be half, and hence for any electron a spin angular momentum is equal to half into half plus 1 into h by 2 pi, and after calculation it will be 3 by 4 into h by 2 pi, and this value applicable for any electron, a spin angular momentum for any electron. Some important point about a spin quantum number: half value do not depend upon principal azimuthal magnetic. It is arbitrary value. Listen, half value do not depend upon principal azimuthal magnetic because a spin quantum number is assumption. In first lecture, I had discussed there are 4 types of quantum numbers: principal, azimuthal, magnetic, spin. But Schrödinger wave equation explained to only 3 quantum numbers: principal, azimuthal and magnetic. A spin quantum number is assumption, and hence value of a spin quantum number is also assumption. But why only assume in fraction? Listen, why assume in fraction? And answer is because a spin quantum number do not relate with principal, azimuthal and magnetic, and value of above 3 quantum numbers are in integer, and hence value of a spin quantum number assume in fraction. That means fraction value do not gives relation between principal, azimuthal and magnetic. Clear? And hence value of a spin assume in fraction. Clear? Next, a spin quantum number only gives a spinning motion of electron, it's on axis. And for any electron, for electron S may be plus half and may be minus half, and hence when value of S plus half minus half for any electron, plus half and minus half both are correct. But plus 1 minus 1 never correct. Only a spin quantum number always either plus half or minus half for an electron. When S equal to plus half correct, S equal to minus half correct. But when two electrons, listen, two electrons, then S equal to plus half. When upward is plus half, then downward must be minus. Why minus? Because, listen, in an atomic orbital, two electrons never in same spin, always be opposite spin, opposite, and hence when upward plus half, then must be downward minus half, and upward minus half, then downward plus. Because in an atomic orbital, two electrons never in same spin. Because I will discuss in next lecture Pauli's exclusion principle. In an orbital, two electrons never in same spin. And in an orbital, maximum two electrons. One electron may be present, but maximum two electrons present. Clear? Now, some question based on quantum numbers. Listen. Which of the following sets of quantum numbers is correct? Which of the following set? Revision. N always natural number. N always natural number. Clear? L 0 to n minus 1. 0 to n minus 1. M minus L 0 to plus L, and S is equal to plus minus half. Clear? Next, which of the following is correct? N is equal to 2. N always natural number, and hence N2 correct. And when N is equal to 2, L is equal to 0 to 2 minus 1. That means 0, 1. 1 is correct. But M equal to minus L 0 to plus L. When L is equal to 1, then M equal to minus 1, 0 plus 1, and plus 2 never possible for L is equal to 1, and hence incorrect. Now, N is equal to 3, N natural number, correct. L is equal to 2, 0 to 3 minus 1, 2, L, 2 possible, and M equal to plus 1. When L is equal to 2, M is equal to minus 2, 0 plus 2, plus 1, minus 1, and hence M plus 1 correct, and S is equal to minus half correct, and hence B number answer is correct. Now, option number 3rd, N is equal to 4, correct, natural number. L is equal to 4. Listen, L equal to 0 to 4 minus 1, N minus 1. So, 4 minus 1, 3, and hence 0 to 3, L. When N is equal to 4, L never 4, incorrect. When N is equal to 1, L is equal to 0, correct. Because L 0 to N minus 1. And when L is equal to 0, then M equal to 0, and hence never plus 1, incorrect. And hence answer B number is correct for the question. Clear? Next, one more question. Which of the following sets of quantum numbers is correct? Again, N always natural number. L is equal to 0 to N minus 1. M is equal to minus 1, 0 plus L. And S is equal to plus minus half. Look at both. N is equal to 5. Correct? Natural number. L is equal to 1. 0 to 5 minus 1. 4. 0 to 4. Correct. When L is equal to 1, M is equal to 0. Correct. Because when L1, 0 to minus 1 plus 1. Correct. And but a spin quantum number never plus 1. It always plus minus half. Incorrect. Now, n is equal to 1, correct, natural number. L is equal to 1. Listen, when n is equal to 1, L 0 to 1 minus 1, 0, and hence when n is equal to 1, L never be 1, and hence incorrect. When n is equal to 2, natural number, correct. L is equal to 1, 0 to 2 minus 1, 1, correct. When L is equal to 1, M is equal to plus 2, never, because M equal to minus L, 0 plus L, and L is equal to 1, minus 1, 0 plus 1, and hence not correct. And last D number, n is equal to 5, correct. L is equal to 2, correct. 0 to 5 minus 1, 0 to 4 will be correct. And when L is equal to 2, M equal to minus 2, minus 1, 0, 1, plus 2, and hence M is equal to plus 1, correct. S is equal to plus half, correct. And D number option is correct. Clear? D number option correct. And in next lecture, I will discuss about lobes, nodes, type of nodes, and type of nodes means radial and planar nodes, and I will discuss about radial and planar node in next lecture. Thank you very much.